So today we're talking about arrays. Lecture 16, arrays. Again, we talked about it last week to a certain extent when I did those loops. But arrays are just lists. They can be lists of whatever. Lists of numbers, lists of strings. We know that strings are lists of characters, right? They're arrays of characters. We learned that back when we were talking about strings. They can be lists of objects, which will be in another class, not this class. But a list, an array, can hold a lot of different data. And it's really helpful because you can loop through the list one by one and get each element. So it helps you organize your numbers. So for example, when I had those 3 numbers, it's a lot easier to sort a list than doing all those individual if statements. There's plenty of sorting algorithms out there for arrays. And so it would have made that sorting a lot easier. But we hadn't learned arrays yet, so I didn't do it. All right. Array is a data structure that represents a collection of the same types of data, similar to a list of data, like I said. Can be composed of integers, doubles, strings, characters, etc. However, if you make a list or an array, an integer array, it can only contain integers. If you make a double array, it can only contain doubles. String, only strings. A char array, only chars. Or char, however you want to say it. Like I said, recall that a string is an array of chars or chars, whatever you want to say. It can be indexed from 0 until string.length -1. So if you look at the string down here, welcome to Java. There's actually 15 individual characters in this string, all the way from welcome, space, to space, Java. There are 15 characters. And so the length of this entire string is 15. However, because in programming, we always start at 0, the indexes go from 0 to 14. So string.length -1. So the length is 15, -1 is 14. So we index from 0 to 14. Okay? Benefits of an array provides an indexable list of same typed data. Right? You can iterate through that list one by one. You can search in a list a lot easier than just having random variables hanging about. For example, if I have 10 numbers I want to keep track of, I can add them to an array. Then I can loop through the array, find the largest number, the smallest number, the average of all the numbers. I can sort it, search for individual numbers if it's in the array. And in Python, there's a lot more powerful tools that you could do just to look for anything in the list. So I could just say, if I make an array of all strings of names, right? Names, I have all these different names in this array. In Python, I could say, is Cardi B in list? And Python will return true or false. It's a lot easier. In Java, you have to do a couple if statements and loop through the array, but it's still possible. All right, so how do we declare an array? Similar to declaring variables, arrays have names, right? Numbers, names. That is the name of the array. And then the data type is what you see over here, the first word. Is it an integer? If it's an integer, you put int, bracket, bracket, or I think those are braces, int, brace, brace, numbers. Right? Those brace, brace tells Java that this is going to be an array. Same thing with double, brace, brace, numbers. String, brace, brace, names. So if you think back to our main method, string, brace, brace, args is an array, right? That's telling Java that it's going to read an array from the console. And that is the arguments that users pass from the console, but we are going to talk about that in the next class. All right, so that's how you declare an array. So how do we actually create an array? Well, you take the array name, you set it equal to new, whatever that array data type is, and then how many elements you want in that array. So if I want a size 10 array of integers, I would say numbers equals new int and put a 10 in there. It creates an array of integers of size 10. Same thing with double. Creates an array of doubles of size 10. And strings, this statement right here creates an array of strings of size 15. However, this number in here doesn't have to be literally typed into the program. You can read it. It can be a variable and say, hey, prompt the user to enter in, or how many numbers do you want to enter in? The user types in 27, right? All right, cool. You would create an array of that size number and then proceed to read in 27 numbers. So what do I mean? Java application, next, lecture 16. So let's say I want to read something in from the console, scanner, so I need a scanner, equals new scanner, system.in. And then I want to prompt the user for however many numbers they want to type in. I don't want to know beforehand. So prompt the user system.out.println, how many numbers do you want to type? Right? Then we would say int number of numbers equals input.nextInt, right? And that's going to be however many, we're asking the user how many numbers do you want to type in following this. So I can do int, let's call it numbers, equals new int, and then however many number of numbers they want to type in, right? So you see in my program, I don't know how many numbers will be typed in. But when it is typed in by the user, I can use that same variable and create an array for all those different numbers, okay? Sorry, let me stay on this a little bit so you can see this. If I'm moving too fast, just let me know. Tell me to slow down. All right. So you can create and declare an array in one step, which is what I just did. So you have it all on one line. Instead of separating it out. All right. So saying int numbers equals new int 10, double numbers equals new double 10, string names equals new string 15. Do be mindful though that you cannot have the same named variables or arrays in the program. So I have this int numbers right here. I can't create a double numbers. It's going to give me an error because there's already a defined variable named numbers in my main method. All right. Again, the scope. I can't have duplicate variable names. I'd have to name this something else, numbers 2 or something. All right. All right, talked about it before. The length of an array or the size of an array is static. Once you create the array of size whatever, it cannot be expanded or contracted. It's going to be that size for the duration of that array. And it's going to be that size regardless if you use all of the indexes in that array, okay? It's always going to be 10, for example, even if you only use 3 of them. It's always going to be 15. Even if you only use 9. And as always, the array is indexed from 0 to size minus 1. So if I create an array of size 10, it's going to go from 0 to 9. And that's what we have here. In order to get the length of an array or the size of an array, you would just use the array name dot length, and that returns an integer of the size of the array. So if I have an array of size 10, if you see int numbers equals new int 10, numbers.length will return 10. Okay, because that's the actual size of the array. But of course, the index goes from 0 until length minus 1, which is 9 in this example. All right. So when you create an array, it has a couple of default values. If it's a numeric array, so integers, doubles, longs, bytes, I think, it has 0, all right, for all the different indexes. Each index starts off as 0. For character and string arrays, it's whatever that character is. And then for Boolean arrays, everything starts off as false. All right, those are the default values of an array. If I create an array, for example, I have this array right here. If I loop through this array and print out each one of the numbers, for int I equals 0, I is less than numbers dot length, I plus plus. You might say, why are you doing numbers dot length and not numbers dot length minus 1? I'm doing that because I is less than numbers dot length. So once I reaches, let's say for example, this array is size 10. Once I equals 10, it's going to break. That way I goes from 0 until 9. And then once it gets to 10, this loop breaks and we're not going to run it no more. So this is a safe operation. I don't have to do numbers.length minus 1. And I do system.out.println numbers at index I. It's supposed to print out 0. Let's see if it does. How many do I want? 10. And they're all zeros. Right? That's the default value. I haven't set anything equal to anything. The default value is 0. All right. So let's go through this example. Int numbers equals new int 10. And again, an array of exactly size 10 is created. All right, same thing if it was 15, 20, 30, 40, is going to be exactly that amount of indexes. All right, creating arrays with literals. I just wanted to add this slide in here. We won't do this too often, but you can. If you know your values, which is not very often, but you can create an array and already put in the values in that array. Right? And you don't have to say the size of it because you're going to type in everything. And the way you do that is array data type, array name equals new array data type. So for example, string names equals new string, and then brace, bracket, and then whatever those values are. So you see down here, I have some artists. So whatever those values are, you put it into the string, and that's how you do it. Again, we don't use string literals not string literals, but literals too often, and we try to avoid them as much as possible, because if you use a literal, it can't be changed. Once you run the program, you might build a huge program. Once you put a literal in, things change. However, that literal is literally typed, and it can't be changed. And depending on how big your program is, it may be difficult to even find where you typed it at. So that's why we avoid literals, but I wanted to add this slide in here in case you ever in the future needed to create a literal array. All right, indexing arrays. So how do we actually access the values in the array, right? The indexes, the individual indexes in the array from 0 into length minus 1. Well, when we access that array, we get that value, it's called an index variable. And we access it by using this type of code. Array name, brace, and then whatever index we want to access from 0 into length minus 1. So if I put in a 5, I'm going to get the 5th index. I put in a 0, I'm going to get the first index, right, at position 0, so on and so forth. And once we index those numbers or we retrieve that number, we can use it like any other variable. So let's say I have my numbers array again. Now I said 5 numbers at index 5 equal to 10. Well, I can use that like a regular variable. I just call that index again. And in this example, I'm creating a new variable, int new number equals 15 plus numbers at index 5. Well, new number will equal 15 plus 10, which is 25. All right. Then I'm going to go through a couple of examples of indexing an array. So again, we have int numbers equals new int 10. So that creates an array of size 10. Let's set number 0 equal to 14. So that sets the index at 0 to 14. Let's set numbers 5 equal to 78. Sets the index at 5 to 78. Numbers 9, 3,829. It sets the index at index at 9 to 3,829. All right. So that's how you access an array. That's how you get the different values in the array. All right. And if you noticed here, the example I was creating over here, I accessed it using I, right? Because I goes from 0 to numbers.length minus 1. So I'm going to get each index in that array with this loop. All right, I believe we left off, we were talking about loops. And let's just go back a little bit. Let's talk about, not loops, arrays. Just what arrays are. Again, they are lists of same type data. So it can be a list of numbers, a list of strings. And we remember, strings are a list or an array of characters, which makes sense, right? Words are composed of letters. So in Java, strings are composed of characters, okay? And if you remember back to last class, indexing arrays, actually, let me do this real quick. All right. Indexing arrays, how you index array is you use the array name, numbers. So for this example, we have an array called numbers. Whatever index you want to go to, and then you can set it equal to whatever, or you can use it as a variable down here. So if we set numbers 5 equal to 10, then we create a new variable called new number equals 15 plus our numbers at index 5. New number will now equal 25, right? 15 plus 10. So here, let's just go through a quick example. We did this last time, indexing an array. So number 0, we set that equal to 14, and you'll see at index 0 will change to 14. 5 to 78, that'll change to 78. And numbers 9 to 3,829, that changes 3,829. So that's how you index an array. And again, this doesn't have to be a literal. You don't have to literally type in the number. You can use other variables that are integers, or you can use a loop. So with arrays, we want to use a for loop, right? We can't use a while loop, but with a for loop, we know that an array has a beginning and an end. The beginning being 0, and the end being array name dot length, right? So that code is for int I equals 0, I is less than array name dot length, I plus plus. And whatever you want to do with that array or the code, you put that inside your for loop. All right, let's say, for example, we have this problem right here. And numbers equals new int of size 10. So we do for int I equals 0, I is less than numbers dot length, I plus plus. And then we're going to set numbers I equal to I times I, all right? So the first time, the first iteration, I equals 0, right? So therefore, numbers at I will equal 0 times 0, or 0. Remember, I equals 0, so numbers at index 0 equals 0. You see right here. So the second iteration. Now I equals 1. Well, 1 times 1 is still 1. So numbers at 1, index 1, will still equal 1. You see that right there. Third iteration. Now I equals 2. So this should be a little bit different. So numbers at index 2 will equal 2 times 2, or 4. And you see that right there. All right? And again, we can change the index of this all the way through. So on the fourth iteration, I equals 3. Numbers at 3 will equal 3 times 3, or 9. There you go. We keep going. 4 times 4, 16. Keep going. 5 times 5, it's going to equal 25 now. And so on and so forth. All right. Let me pull up something real quick. All right. We keep going. The pattern just repeats itself. 8 times 8 is 64. And then 9 times 9 is 81. All right. So that's how you loop through an array. And I'm going to show you an example of that now. All right, let's go through some of these examples. So initializing arrays with input values. So for example, let's read in the size of an array. All right. Let's read that in. New project, Java application, lecture. I think we're on 17 today. All right. So if we want to initialize an array with input values, that means we need to read something from the console. All right. And anytime we want to read from the console, we need a scanner object. Scanner input equals new scanner. All right. Anytime we want to read from the console, we need a scanner object. And of course, you can click over here to import the java.util.scanner, or you can hit Control-Shift-I. Okay. All right. Once we have a scanner object, we can read from the console, but now we should tell the user what to type in. So to tell them system.out.print, we use the system.out.print to tell them in the console, hey, enter something. Enter the size of array 1. Right? I'm missing my semicolon. All right, now I'm telling the user to enter the size of array 1. Let's actually read in that size. Double size 1 equals input.next. Actually, it should be an int. Okay, so that reads in the first one. If I run this, you'll see down here, it says enter the size of array 1. I can enter in 25. And it's reading in that size. It's just not doing anything yet. Well, let's create an array. So int, let's create a string array. String vehicles equals new string. Let's make it size I. Right? Now, whatever I type into the console is going to be the size of our array. Then we can loop through this array for int I equals 0. I is less than vehicles.length, right? That gets the full size of our array. We could also do size 1, but either way, you would have the same number, I++, and then inside our for loop, let's just, I don't know, what do we want to set this equal? Vehicles at index I equal to, let's do vehicle, and then concatenate I in there. So it's going to say vehicle 0, vehicle 1, vehicle 2, vehicle 3. Once we do that, let's print out each index. I is less than vehicles dot length, I++, right, and then system.out.println vehicles at index I. So we run through this again, line by line. The first line I'm doing is creating a scanner object so I can read from the console. System.out.print prints to the console, and I'm just prompting the user to do something. Enter the size of array 1, right? That's what it says down here. And then the next line, int size 1 equals input.nextInt, I'm waiting to read something from the console. So when the user puts in a 25, it reads in that from the console, creates a string array of size, whatever the user enters into the console. Then we're looping through that array. So if I put a comment here, loop through array and set indices to vehicle and concatenate I. So what we're doing is setting each index to the word vehicle plus whatever number I is. So 0 all the way up to vehicles.length. And then once we do that, I'm looping through the array and print each index. That's what this loop is doing right here. System.out.println prints to the console, and I'm printing each index of that array. So if I run this, I put in a 5, you see it creates an array of size 5, and it prints each index, 0, 1, 2, 3, 4. Right? And in programming, we always start from 0, particularly with arrays. Any questions about reading in the size of an array from the console? All right, so let's initialize an array with random values now. So instead of reading it in from the console, let's make size 1 a random value. And how do we do that again? We need a random object. Random rand equals new random. And there you go. Same issue with the scanner. You can do click over here and import java.util.random, or you can do Control-Shift-I. All right. I hope that's the right random. This one should not be imported. All right. And so instead of input.nextInt, we do rand.nextInt. Right? And now it's going to give us a random integer. And whatever that size is, let's put a maximum size in here just so it doesn't get anything crazy. So it's going to get an integer from 0 to 20. Let's see what it gets. So in this one, this instance, the random variable is 12. 0 to 11 is 12. And this one, it was 11. This one, it was 0. This one is 6. This one is 7, 8, 4. And you see it's a random number each time. I did give it a max of 20 just so it doesn't get anything crazy. Questions on what I'm doing here? Again, you can put it in the private chat. I don't mind. stopping class. I want this to be a conversation. I don't necessarily like lecturing for 50 minutes. All right, if there's no questions, I'll keep going. And I'll actually let this sit here for a second so you can look at that. All right, let's go to the next one. Well, printing arrays, we just did that. I printed it down here. System.out.print line, v equals I. So that's how you print the array. You would just loop through and print each index. And again, this array could be any name. It could be numbers, it could be strings, it could be really anything. I could read this in from a file. Finding the largest element. All right, obviously with strings, there is no largest element. So let's change this into an integer. So let's say instead of string, let's do int scores equals new int of size 1. Right? Let's say these are game scores. So let's loop through the array and let's set scores at index I equal to, let's do some realistic scores. Individual player scores, so basketball players. Let's say rand.nextInt, and these days James Harden is scoring upwards of 60 points, so we're going to put the max at 60. Okay. And let's say each person or whoever we're calculating their scores for, they played all 82 games in the NBA season, right? So what this array represents is that player's scores for all 82 games. Now, obviously, their scores can range from 0 all the way up to 60, okay? And so now, if you think about in basketball, a player plays all 82 games, and hopefully they scored every game. Some players don't even play every game. But if they scored every game, we can put that inside an array and then calculate their highest scoring game of the season, their average points per game, so on and so forth. Just a second. All right. So that's what this is doing. It's just putting a random number in there for each individual game. Okay. So now if we have this, if you remember a couple classes ago, we did the max. I believe, let's see, okay, Java doesn't have a built-in function. Some programming languages have built-in functions to find the max. Java does not. So we need to find the max. So int maximum equals, and remember, we want to set this equal to the lowest possible number. So therefore, when we get inside an array, anything higher than that, the max will be set to it. Equals integer dot min value. That's the minimum possible value. So therefore, when we get inside the array, anything higher than that, which all numbers should be higher than this, we'll replace that maximum, and each time we'll find the max. Scores.length. Actually, let's not change this one. Let's keep this one. It prints out our array. And then let's put this on print. All right. So right here, let's loop through the array, and find max. All right. So for and I equals 0, I is less than scores dot length, I plus plus. We are looping through our array again. Now we have to check if the current index of I is greater than our maximum. If scores at index I is greater than maximum, right? That means that it's higher than our current max. Let's set our maximum equal to scores at index I, because that number is bigger. All right. Once we finish that, our maximum should equal whatever the highest or biggest number is in our array. And we can just system.out.println the highest score is, and then let's print maximum points. All right. So let's debug this so we can see line by line what's going on. So if I hit the debugger, it stops down here. All right, if we look at our variables down here, all right, we have scores. Scores is of length 82. If I click into this, we can see all these different points this player scored. They scored 46 in game 1, 34, game 2, 54, game 3, then 7. They're not very consistent. And all their scores for the season, they are not consistent at all. But they might have a pretty decent average because they're scoring over 50 points a game in some games. And you see our maximum is -2 billion, 2 trillion, something like that. So we know for a fact all of these scores are going to be greater than this. So it's going to be replaced. So right now our program is currently on this line. We go to the next line. If scores I is greater than maximum, well, scores I, because I is equal to 0 right now. So scores at 0 is greater than our current max. So it's going to replace it. You see now our max is 46. Goes to the next, back to the top of the loop. Go through again. Is scores I greater than our current max? Scores I, 34 is not greater than 46. So it's going to skip over that. Now, is 54 greater than 46? Yep. So our current max is 54. And it's going to continue this process all the way until we get here. I'm just going to hit this button, and that jumps all the way down to our next line. And we see that the max points this player scored was 57. All right. That was the max points they scored. We print that out. We go to our output. The highest score is 57 points. And then the next line down here, this loop will print out all that player scores for the full 82 season. And you see that's how many different sporting companies, if you will, NBA, NFL, they keep track of all these different players. They just use arrays. At the core, behind all of those websites and apps that you use are arrays, especially with player stats. All right. Finding the smallest index of the largest element, that's a little bit different. So if there's repeats of the largest element, you could find the index that's closest to the front, yada, yada, yada. You can also sort arrays. So you see how we have all these, and before, you know, we had to do all those sorting with if statements and all that good stuff. We don't really have to do this, but keep in mind that when you do sort, you lose track of the index. So you wouldn't know if it was game 1, 2, or 3, or 4 that he scored the points. You would just see that the whole array is sorted. So maybe you don't want to do sorting for scores. You want to do sorting for if you have, it actually makes it a lot easier. If you just have a random array of numbers, right? We just have a random array of numbers. So instead of scores, we just say numbers. And let's set this equal to 20, right? We just have a random array of numbers. So what I'm doing here, I have this array. It's of size 20. And then for each index, I'm setting it equal to a random number between 0 and 100. Okay? So let's try to find the max again. However, this time, actually, let's do greater than 20. Let's do 1,000. So we have a fairly large array, right? Looping through this whole array to find the max is a bit inefficient. And we could just sort this array. And then once we sort it, the biggest number will either be at the end, if we do it in increasing order, or at the beginning of the array, if we do it in decreasing order, right? So if we sort the array from biggest to smallest, that first one will be the biggest. If we sort it from smallest to biggest, the last one will be the biggest, and the first one will be the smallest. So it makes it a lot easier to do that. So I believe in Java, there's something called arrays.sort. Yep. And then you just pass in your array, and it sorts your array. Now I believe it sorts it in, let's see, arrays.sort ascending order. So from 0 or the smallest to the greatest, it sorts in ascending order, okay? So once we do that, once we sort our array, look how much easier it is to find our max. Int maximum equals numbers and then the last index, which is numbers dot length minus 1. That is our last index. And now we found the maximum because we already sorted the array. System.out.println, the max is, and then we just concatenate our max. So once we sort it, it makes it a lot easier to find that max. I run this, our max is 99. See, that was so much more efficient than running through the whole array trying to find that max. By sorting it, we can do that. However, again, if order is important, so when we have our scores, order is important. So we don't necessarily want to sort the array. But if we just have random numbers, we're trying to find the largest, sorting it does help, okay? Any questions about arrays, looping through arrays, sorting arrays, any of those questions? What arrays are? Should I review it?
Yes, sir.
You said no or yes?
Yes, sir.
Yes, review it? All right.
Yes, sir.
All right, that's cool. All right, we'll review it real quick. Go back up to the top of the slides. All right. Okay, arrays. Arrays are lists. Okay, that's all they are, lists of numbers, of words. And if you remember, strings are arrays of characters. So they're lists of characters. And with that list, they're indexable, meaning you can get specific indexes within that list from 0 up until the list.length. And we declare our arrays using whatever data type we want our array to be composed of, and then open brace, close brace. So if you look at my code, that's what I did right here. Int, so I want this to be an array of integers, brace, brace, the name of my array, and then in this line, I'm actually creating my array. So if you look at the slides, you can do that in a couple of different steps. You can declare the array first and then create the array in a different line, or you can do it all on one line here. And I'll show you that in the code. So right now, I did this all in one line. But let's say, for example, depending on a certain condition, I want my array to be a different size, right? So let's say, let's get a random if size 100, Boolean size 100. Let's just declare our array up here. create a Boolean equals rand dot next Boolean. I'm just getting a random Boolean here, right? And what I'm going to do is, if this Boolean is true, I'm going to make my numbers array size 100. If it's false, I'm going to make it size 10. So if size 100 is true, numbers equals new int size 100. Else, numbers equals new int size 10. So that's when you would do it in different lines. If there's a specific condition that you want your array or the size of your array to change based upon, you would initialize it or declare it in a different line up here and then create it on a different line. But if the size is not based on a condition, you can do all the declaring and creating on one line, which is what I did up here. So equals new int size 1000. So I did everything on one line up here. Okay, that's how you declare the array. This array is of size 1000. All right, I'll let that sit there for a second. Again, arrays are just lists which you can be composed of numbers, words, characters. However, once you create the array, you cannot put in a string into a integer array. You can't, well, you can't put it into a double array because they're converted, but strings and number arrays are incompatible, okay? All right. And then to get the size of array, so for example, let's say we don't know what this size is. It's just a random dot next int. We don't know what the size of this array is, right? I don't know what that random number is going to be. It could be 2, it could be a billion for all I know. But there is a method available to us that gets the length of an array without us having to know it. And that is the dot length method. So you use your array name, dot length, that gets us the length of the array, right? And we don't have to know the length. The program will know it at runtime. And that's how you would loop through the array. So you create your for loop for int I equals 0, I is less than numbers dot length, right? We know the length of the array. We don't necessarily know what that specific number is, but we know this method is going to return the length of our array regardless. And then to actually access the indices of an array, we use our array name, bracket, and then whatever index we want to go into. So for this example, I'm looping through it. So I want that index to go one by one through the array. I starts from 0 and goes all the way up to numbers.length minus 1. Okay, because once it equals numbers.length up here, that array breaks. It'll never go down here. But the whole while it's less than, this array will keep going. I mean, this loop will keep going. All right, and so in this example right here, what I'm doing is I'm indexing into my array at index I, and I'm setting whatever that index is equal to a random integer between 0 and 100. That's what I'm doing here. I'm just setting each index equal to a random number between 0 and 100. Down here, I'm sorting the array. Arrays.sort sorts the array. It's really straightforward. We don't even have to come up with our own sorting algorithm. I don't remember or recall which algorithm it's using, but it's fairly efficient. There are many different sorting algorithms that I'm sure you'll learn in your algorithms class. Then to find the max, once we sort the array, finding the max is trivial. Because a sorted list, we know that the max is either at the beginning or the end, if it's sorted. So int maximum, and based on this method right here, it sorts it in ascending order. So smallest to biggest. So what that means is the last index in our array has to be the biggest if the array is sorted. And that's what I'm doing down here. Int maximum equals our array name at index numbers.length, which is the full size of the array, -1. And I do the -1 because our array goes from 0 to numbers.length -1, right? The last index is the size of the array -1 because we start at 0. And then finally, I'm printing out that maximum number, which in this case, actually it doesn't like what I did. Let's do that right there. In this case is 99. But if we do a much larger number than 100, our greatest number may be something a lot bigger. That's our biggest number in our array. If I run this again, it should be something different. Again, something different, because those are random integers. Does that make sense?
Yes, sir.
All right. All right, last thing with arrays, the last thing. There's something called a enhanced for loop, which in this class we don't really have to worry about, but I did want to show you it. Basically, you don't have to use the int I equals 0, I is less than yada, yada, yada. You can just create a variable and it loops through the array, and the value of that variable changes for each index. So instead of this right here, now I'll show you why it's good and why it's not. I can't set the index equal to anything. And I'll show you the actual loop I'm talking about. So for int num numbers. All right. So I created this for loop right here, int num numbers, colon numbers. What this does is it loops through the array, and each time it sets num equal to the next index, right? So if I want to just loop through the array, find the maximum, I could do this. However, if you notice, I can no longer index into this array and set them equal to anything because I don't have an index number. I don't have an I to keep track of what index I'm on. I can't do this numbers num. That doesn't work because num equals the value of numbers at whatever index it is. Okay, so just to show you this, let's say we do this line. We set everything equal to a random integer, and then for int num in numbers. What I mean is, it's going to go through each time num will equal the next index. So system.out.println num. All right. Num will equal whatever numbers are in our array. So if I debug this and look at our variable, in our numbers array, our first number is 146,143. That's our first number. So if we go into num, this array right here, if I jump through this one, system.out.println, num equals our first number, then our second number, then our third, then our fourth, fifth, sixth. Again, since I don't have an index in I equals 0, I can't change any of the values in my number array, but this is good if I just want to loop through the array and get each value. I don't care about what index it's in. I really don't care about changing the array. I just want to get the individual values. Again, in this class, that's not very important. We probably won't do that a whole lot, but maybe in the future you might. Okay. All right, and that was the last thing about arrays. Any questions?
This PowerPoint is going to be posted, right? What
Yep.
I like it.
Yep. I'm going to try to post it before Friday, if not today. I got to cut last class and this class together, so that takes me some time. I'm not a video editor, but
Well, I'm all good. Man. If it's going to be posted, I'm good.
all right. All right, so that is arrays. We're done for arrays.